Alright, so we have this problem for test for convergence. We're going to see if pretty much going to try to figure out if this problem converges or not. One of the first things, since it has factorial, that should be an automatic hint to use the ratio test to see if it converges. So let's put a hint. Factorial ratio test. Alright, so we're going to start with the procedure for the ratio test. In the ratio test, you pretty much, the procedure is you have to add 1 to every k and then multiply with the reciprocal and take the limit and then determine if it converges or diverges. So let's start with adding the 1. So the first. Alright, so now that we know we have to use a ratio test for this problem, let's just go ahead and start with the ratio test, the procedure. The procedure for the ratio test is you have to replace k with k plus 1 and then multiply by the reciprocal of the problem and cancel everything out and then take the limit and see and use the ratio test criteria to determine if it converges or diverges. Alright, so let's get started. One thing I want you to notice is that I will be replacing the k with k plus 1 instead of just writing k plus 1. Because if you just write k plus 1, this will be 2k plus 1, which is actually wrong. It's 2k plus 2. Because the way you would write it is k plus 1, like that. So as you can tell, once you distribute the 2, it will be 2k plus 2. Which is very important because that can lead you to a wrong answer very easily. So make sure you take very good care when you're writing these. Make sure to replace the k and not just write k plus 1. And on this note, you see how this pi raised to the negative k? The negative just means that it's the reciprocal, 1 over pi to the k, so I'll just write it at the bottom. So I'll just write it up here, k plus 1. I'll just take the negative out because this is in the numerator and this is in the denominator. It takes care of the negative. Alright, so now I will rewrite the problem to distribute all the 2's and all the constants and stuff. So let's get started. Alright, you see how I just pretty much separated k to the k plus 1 to k to the 1 times k to the 1. And that's just a simple algebraic property that pretty much just lets you know that if you have the same base, you add the powers. That's a simple algebraic property. So I use that to separate them. So this is the front. Now we're gonna multiply with the reciprocal, the same problem as I said earlier. So multiply. The reciprocal would be I to the k times 3k factorial over 2k factorial times 2k factorial. Alright, so now that we have this set up, let's start canceling stuff out. Alright, so one of the bigger properties that you have to understand that in factorials, that the way factorials work is it pretty much multiplies and it does, and it subtracts 1 each time. So it'll be n factorial will be n times n minus 1 times n minus 2 times n minus 3. So in this case, you can rewrite the same thing as, let's say, 2k plus 2 times 2k plus 1 times 2k factorial. That's saying the same thing as that. So let's do that and write it over again. So we have 2 of them. 2k plus 2 times 2k plus 1 times 2k factorial. Alright. Now for the denominator, we have 3 of these, so I have to write it 3 times. 3k plus 3, 3k plus 2, 3k plus 1, 3k factorial times 5 to the k times 5. Now the reciprocal, 5 to the k times 3k factorial over 2k factorial times 2k factorial. So now we can simplify. This cancels that. That cancels that. That cancels that. That cancels that. So leave us with that, these. Alright, come here now. So now as you can tell. Alright, so now as you can tell, we have pretty much a factored out equation, and the way ratio test works is you have to take the limit. You have to take the limit of this. So come here and write limit of k approaches infinity. Alright, so you pretty much have to take the limit. So if you take the limit, let's look at the k's. 1, 2, 3, 4. If you multiply all of them and factor it out, you will get k to the 4 at the top, and some constants and a lot of variables that has a lower power, which doesn't matter because we only care about the higher one. Let's look at the bottom. We have 1, 2, 3. So it's going to be k to 3. This is a very simplified version of the equation we just saw, because when you're taking the limit as k approaches infinity, smaller power doesn't matter and constants doesn't matter. First thing we need to care about is the power of the equation. So we're going to be taking the limit of this. This easily cancels out to be just k, and the limit as k approaches infinity is infinity. And now the ratio test tells us, ratio test criteria, if k is more than 1, diverge. K is less than 1, converge. K is equal to 1. I don't know. Yeah, no, literally, if k equals 1, you don't know, and you have to use a different method. You really don't know. If you get k equals 1, you really don't know the method, and you have to try with a different method. You don't know the answer. So you pretty much have to see if it's k is greater than 1, less than 1. If it's greater than 1, divergent, less than 1, convergent, equal to 1, you really don't know. So in this case, it's if k equals infinity. Infinity is greater than 1, so diverge